here we go. 5.1c. Continuing finding extreme values. We're going to do them with other functions, though. We're going to have some trig functions happening. I do let you use your calculator on those, though. And then we're also going to have a piecewise graph we're going to look at. That's kind of fun. Okay, so we're just going to do about 7 problems, and then I have a review worksheet for us to practice too, so that everyone's ready for the quiz on Friday. All right, number 1. We're going to find all max and mins. So extrema is what they call it, extreme values. And here's the first function. Here we go. F of x is equal to x over x squared plus 9. Okay, so as you can see, it's not a polynomial. It's going to be a little bit harder than that. And we're going to find all of them. And I didn't give you an interval, so there's no endpoints to check. Okay, so you have to check 3 things. Endpoints, derivative is 0, derivative is undefined. So our first step is to do what? In calculus, your first step is usually to take the derivative. Yes. All right, so let's go ahead and take the derivative. Now, we're going to take the derivative of this. Do you remember how to take the derivative of that? We got to use a rule. Quotient rule. We got to do quotient rule. No, it's x squared plus 9 on the bottom. If it was flipped, yeah, you could go ahead and split it up and then reduce. All right, so here we go. Low d high minus high d low over the square of what's below. Let's do it. So low, x squared plus 9, low d high times 1 minus high d low over the bottom squared. Okay, and let's fix this. So up top we have x squared plus 9 minus 2x squared over stuff. And then fix one more time. We have negative x squared plus 9 over x squared plus 9 squared. Okay, so we've taken the derivative. Yes? No? Did I do it right? We have x squared minus 2x squared gives us negative x squared. Okay, so let's set this equal to 0 and solve. By the way, first, before we do that, let's look at where this is undefined. Is this ever undefined?
Yes.
No. No real numbers.
Plus and minus 3, right?
No.
Oh, not on that.
Yeah, because there's a plus there. If there was a minus here, we'd be in trouble. But because, the derivative has a x squared plus 9, so there's nowhere where this is undefined. So let's set it equal to 0 and solve. Now to find out when a fraction equals 0, it's really when the numerator equals 0, right? 0 over 5 is 0, 0 over 10 is 0. So we really care about the numerator. If that bothers you, you can always put this over 1 and cross multiply if you wanted to do it that way. And you get 0 equals negative x squared plus 9. I would probably add x squared over to the other side. X squared equals 9. And we got plus and minus 3. Plus or minus 3. Okay, so those are going to be our critical points. We're going to go back up to our original function, and we're going to find out what they are. Are they a maximum? Are they a minimum? What are they? Bless you. All right, so here we go. We've got 3. We'll plug that in, and we'll plug in negative 3. So if you plug in 3, you get 3 over 9 plus 9. So 3 over 18, so 1/6. Okay? 1/6. And then plug in negative 3. You get negative 3 over 18, which is negative 1/6. All right. Pretty easy to decide. At this point, since we aren't testing really for it yet, I would let you graph this on your calculator just to make sure that you can see what they are. Okay, I don't have a problem with that at all. I know some people do, but you guys are glad that I don't. All right, so go to your calculator, and we'll go to y equals, and we'll graph x divided by x squared plus 9. Okay, there it is. What? What did I do?
Check your mode.
Mode. Mode's good. Zoom 6.
Did you turn the sound off?
I did. Did anyone get a different thing?
Do you have it in the right mode?
Yeah, yeah, mode doesn't matter. Huh. Where's my old calculator? Huh, maybe I'm going back to my old calculator. Let's see. Did anyone graph it?
No.
No? Because you're all too lazy or what?
Yeah.
Oh, all right.
Just go
Yeah?
zoom and then 0.
Oh, so that new calculator, I'm not really used to it yet, huh? Here's my old calculator.
Same thing.
You hit zoom fit?
Zoom 0. Yeah,
Zoom 0. Oh, okay. Ooh, that's a really pretty graph. Okay. Will that work over here too?
Yeah.
So excited for this thing.
Do you like it? You can do like the different color lines on that one?
I haven't really done much on this yet. Yeah, that's better. Thank you. Zoom 0. What is zoom 0? Zoom fit? You guys use that a lot? Yeah? Is that a physics thing?
I don't graph.
No? It's just a calculus thing. Okay. You don't graph. I don't really graph either. Maybe that's my problem. Okay, so as you can see from the graph of the function, I didn't graph the derivative, okay? I graphed the function. It dips, and then it goes up like this, okay? And so at -3, we see that we're down here at -1/6. That's a minimum of the graph. It's an absolute min. And then up here, we're at +1/6. That's an absolute max. It's so nice to have the calculator just to see it. I mean, we did all the work analytically. We kind of just checked it graphically. So this would be a max, and this would be a min. All right, that was a good problem to start with. Now, let's do one graphically, because we haven't really done one solely graphically yet. So let's do number 2. Let's do f of x is equal to the sine of 2x. And let's give ourselves an interval from 0 to pi. Okay? And let's find all the critical points on this graph. And I would let you graph this one. You know, I might ask you to find the derivative first, just to make you find the derivative of this, because, you know, we're in calculus, so we should. What would the derivative of sine of 2x be? Do you remember how to take that? Cosine of 2x, and then? Times 2. Chain rule. Okay? So that would be the derivative. And if I were going to do this analytically, I'd have to set that equal to 0 and solve. But you guys haven't solved anything like that since trig, right? Yeah. So let's go ahead, let's go ahead and graph the sine of 2x on our calculator. All right, so the sine of 2x, and I would tell you on your quiz, graph it. It's fine. Yes, I know. Isn't that crazy?
No, you don't have to use the unit circle.
No.
I did the homework and I don't have to use the unit.
You did it better, though. You did it the way you'll do it in college. This is just kind of getting our feet wet. This is not an AP class. I know you're not used to this, huh? Welcome. All right, I would probably use Zoom trig on this, and then I would probably go back and fix it, because that's a lot of maximum. There's actually an infinite amount of maximum minimums on this graph, right? Because it goes on forever. But I've restricted it from 0 to pi. So let's go to my window and do x is from 0 to pi. And then graph it, and then it's nice and manageable here. Yay. Okay, so first thing you want to do is you want to put your endpoints in. So 0 and pi are endpoints. And if you had it graphed, you could just trace and go, drugs are ready, turn off. Yeah. All right, and then you get y is 0, which you can see. And if you plug in pi, you get the sine of 2 pi. And what's the sine of 2 pi? It's also 0. Okay, wow. And so they're different, though. This 0, 0 right here is a minimum on the graph, and this pi 0 is a what? Yeah. It's a max. You see that? Yeah. Okay, and then we have this one right here, which is a maximum. Where do you think that's going to be?
1 point.
Let's see. This is 0 to pi. Pi over 4. Let's see. Trace. Let's go pi over 4. Hit enter. There we are at 1. Pi over 4. 3 pi over 4. Good. So pi over 4, you hit 1. That is an absolute max of the graph on this interval. And then 3 pi over 4 is -1, which is an absolute min. Will this graph have an absolute max and an absolute min?
Yeah.
Yes. Why? 2 reasons.
Closed endpoints.
And
Continuous line.
continuous. Good. We're on a closed interval, and we know that that is a continuous function.
I do birthday parties too.
EVT.
EVT.
EVO. Do you know what EVO is?
Yeah.
Any cooks out there? Okay, here we go. Number 3. Let's do a piecewise function now. Y equals x plus 3 when x is less than 1, and -2x when x is greater than or equal to 1. All right, so personally, if I wasn't given my calculator, I would graph this thing and take a look at it, look at the maximum minimums. You don't need to take the derivative. Derivative of this is 1, and the derivative of that's -2. But something's happening at 1, right? Something weird's happening. So I would just graph this. I would go ahead and go to 1 and plug in 1 into this first section here. And if I plug in 1, I get what? 4? And that would be an open circle. Okay. And then if I plug in 0, I get 3. So this is just a line going in that direction. So x is less than 1. The other side of it, this side right here, I plug in 1 and I get -2. And then I could plug in 2 and I get -4. So I'm going down here. Okay, so let's talk about this graph real quick. Do you see any maximum or minimums? There's just one. What is it? The point 1, -2. 1, -2 is a what? It's a max. It's a maximum right here in that neighborhood. All right, so piecewise functions, we don't really do them too much, but there you go. Okay, now I'm going to give you one that you have to draw for me. Are you ready for it? Okay. Here we go. You're going to draw a continuous graph, draw a continuous function. What's that? Draw a continuous function that has an absolute max at 3, 5, an absolute min at 5, -2, and it's on the interval from 0 to 10. And look how I wrote 0 to 10. 0 with a parenthesis, 10 with a bracket. Okay, so draw a continuous function. There's going to be an infinite amount of answers here. Someone could be right over here, and someone could be right over there, and you can have different graphs. That's fine. But go ahead. You want to try this on your own real quick? Yeah, I'm going to let you try it. All right, so what I would do is this. I would draw a graph 0 to 10. I would put a point at 3, 5. 1, 2, 3, 1, 2, 3, 4, 5. I would also put a point at 5, -2. And then you could just draw a boring old polynomial, right? So I would go ahead and put an open circle somewhere on 0, on x equals 0. It doesn't matter where. You might have went to the origin or something. And you're just going to go up to that peak and down to this valley, and then you'll end at 10 somewhere. You probably ended right there, huh? Yep. Anyone look like that a lot? A lot like mine? Yeah. Okay. There you go. All right, how about you now draw a graph that has no max and no min. No max and no min.
Has to be continuous now?
No, not necessarily. Just a graph that has no max and no min. You got one? Yeah, there's lots of answers. What'd you do? What are you thinking? Just a straight line?
Yeah.
Does a horizontal line have a max and min? If I drew a horizontal line with endpoints, it has a max and a min. It has to, because it's continuous and it's on a closed interval. But still, are those considered all maximums or all minimums? What are those? I'm not sure. I know, right? I think I would need to talk to Mrs. Pfeiffer about that. For me, just to be safe, what I would do is I would put an open circle and an open circle. That's what I would do, just to be safe, because I'm not sure about this right here.
But if it's horizontal with the open circles?
See, I don't know.
See, because you could say the same thing about the
right? That's true. I think open circles would be okay.
Let's make a vertical line.
That's not a function, but I didn't say, oh, it had to be a function. Yeah.
Draw a graph.
Yeah, I didn't say function, but it should be a function. You could also, did anyone think of just a cubic function too? That has no max, no min. Yeah. It's pretty good. No? All right. Okay, let's move on. Why don't you guys practice this one real quick? Just because I don't know if you're doing a lot there. I'm going to give you a polynomial. F of x equals x cubed over 3 plus x squared over 2 minus 6x on the interval from -5 to 5. And I want you to find all the extreme points, extreme values, okay? And tell me what kind they are. There's no calculator on this. I know, it's tricky, especially when you have to plug them back in. Maybe I'd let you do that. I don't know. I got yelled at one year. For me, I like to start with the endpoints. So I'm going to take -5 and plug that in. And I get a fraction. Do you get a fraction? 0.83 repeating.
That's what I got.
Yeah?
Oh, did you just input it into your calculator?
I did, but 0.83. So, or a fraction. And then when you plug in 5, you get 24.2. Yes? Are those the numbers you got? Okay. All right. And then I'm going to take the derivative. So those weren't very nice, but when you do take the derivative, it turns out super nice. 3 comes down, reduces. By the way, if you look at this as x cubed over 3, some people might think quotient rule, but this is the same thing as just 1/3 x cubed. If you want to rewrite it like that so it's nicer to look at, you bring the 3 down, the 3's reduced, and you subtract 1 off. So then the derivative would be x squared plus x minus 6. Okay, because the 2's will reduce here. And I designed it that way so that it would be something that when you set equal to 0, you could factor very easily. So we get what times what's -6 adds up to 1 would be a +3 and -2. Good. So then I would get x is -3, x is +2. Those are also going to be critical points. When I plug -3 back into my function, I get, oops, trace, -3, I get 13.5. And when I plug 2 back into my function, we get -7 1/3, so -7.3 repeating. Okay, so now I have 4 points to discuss. For me, what I like to do is, you know, you can just look at them. You can put them on a number line. You can kind of graph them in a way. So at -5, I'm at 0.83. So that's right around here. My next point that I'm looking at is -3. I'm up here at 13.5. My next point of interest is down here at -7. And then my last point is up here at 24. So the graph that I'm looking at looks like that with endpoints. Okay? So it's going to have some maximums, some absolute maxes and absolute mins. So let's see. The absolute min would be this one right here. That is the lowest point of any of the y's. My absolute max is 524.2. Absolute max there. 0.83, -5.83, that would be a minimum. You go up from there, min. Just a relative minimum. And then what's the other one? This one? Yeah. Yes, relative max. Good. You can just call it a max if you want to. Okay? That's what the quiz is going to be like. A lot like that. There'll be one like that, polynomial, nice and easy. Okay? All right, so